Hi mathematicians, in this video we're going to learn how to interpret a y-intercept. Quadratics model projectile motion. Let's look at some examples of projectile motion. One classic example is a rocket taking off. The rocket goes up and then comes back down again. Here's another example. A ball falling off a cliff or off a great height or a building. These are some examples of projectile motion. So here we have an example. The height of a rocket at select times is shown in the table below. Interpret the meaning of the y-intercept in the context of this problem. We can find the y-intercept by looking for where our dependent variable is 0. In most cases, that's time. So our time is 0 right here. So our y-intercept is 0, 180. Now we need to interpret the meaning of this. Well, at time equals 0, that means at the beginning or initially. So initially, or at the beginning, the rocket is 180 feet up. So we can say the y-intercept represents the initial height of the rocket was 180 feet. So in this rocket launch, the rocket was up a little bit before it took off. So that initial height of the rocket was 180 feet. Let's do another example given an equation. This question says the height h in feet of an object dropped from the top of a building after t seconds is given by h of t equals negative 16t squared plus 144. How many feet up was the object initially? So when we see this word initially, that tells us we're looking for the y-intercept. The y-intercept in an equation is the number with no variable. So our y-intercept here is 144. We could also find that by putting it in our calculator. Press y equals and put this equation. And instead of t, I will put x. Negative 16x squared plus 144. Now I can look at my table and see when t is 0, or when x is 0, my y-intercept is 144. So our y-intercept is 144. That means the object had an initial height of 144 feet at 0 seconds. Let's do one more example with a graph. A ball is thrown into the air from the edge of a 48-foot high cliff so that it eventually lands on the ground. The graph below shows the height y of the ball from the ground after x seconds. So that's similar to this example where they're on a cliff and they throw the ball to the ground. So let's find and interpret our y-intercept. Well, our y-intercept is where the graph touches the y-axis. So here our graph touches the y-axis at 48. So we can say the y-intercept is 0, 48. Now what does this mean? That the ball is thrown from the edge of a 48-foot high cliff. So the ball was at 48 feet high at 0 seconds initially. So that's 3 examples of interpreting the meaning of the y-intercept in a quadratic. Good luck with the next question.